I think ZK could actually be much bigger outside blockchain. What is original and genuine content made by a human and which one's not. So we can drive down the costs by about 90% compared to traditional cloud compute providers. Launch the final ZK cloud, which is going to be entirely permissionless and decentralized.
Hello and welcome to the new episode of Gateway.fm podcast. And I'm excited to have Norbert from Gevulot here with me. He is a pro in ZK field, so zero knowledge is the topic of the today podcast. Norbert, could you please a little bit introduce yourself, tell about your experience in ZK and how you end up in blockchain area?
Thank you. Hi, Alex. Hi, everyone. Thanks for having me. I'm Norbert. As you mentioned, I'm working as a protocol researcher, but also on the product side at Gevulot. And basically, we are building the first universal proving layer optimized purely for ZK. We support any proof system. Users can generate proofs fast, cheap, on a decentralized network. That's in a nutshell about us, and happy to delve more into any details.
Yeah, let's start with very basic things. Like for those who are not familiar with the technology itself, how would you explain the zero knowledge concept in simple words?
So there are two types of proofs, and I think it's important to talk a little bit about this because there are validity proofs and there are zero knowledge proofs. The difference is both of them use the same technology, basically. We are talking about snarks in both cases, but one of them is a ZK snark, while the other one could be described as a normal snark. The difference between the two is that in case of a ZK proof, you also cover the privacy aspect, which means that you know some statement or you are in the possession of some information which you want to prove exists and you want to prove some property of it, but you don't want to reveal the information. Usually, so that's ZK proving, and usually the rollups out there are not covering the privacy aspect. When we are talking about scaling solutions of Ethereum, for example, L2's rollups, in those cases we are usually talking about validity proving and validity proofs, which means that these proofs actually confirm and verify the validity of the state transitions and the transactions that have been rolled up or bundled up into a block on a rollup, but they don't cover privacy. It's just important to mention, I think, because usually nowadays we hear everybody just saying ZK proving, but actually ZK proving, like in a strict sense, includes the privacy aspect as well, while in case of a rollup, we are talking about scaling solutions and we are talking about verifying the correctness of the execution of those rollups and the state transitions of those rollups. I don't know if it's a good enough explanation in a nutshell, but yeah, I think it's an important element.
Definitely. So taking rollups as a one application case of ZK technology, are there any other application cases?
Actually, there could be many. I mean, any application that would like to verify either the underlying data, the transactions, or the computation involved, or computation executed over that data, for example. For them also, the technology could be super useful, but I think overall, looking at the space and looking at use cases like real-world use cases, I think ZK could actually be much bigger outside blockchain than within blockchain. And what I mean by this is that, for example, we have tons of new content coming out, AI-generated content. And like 10 years ago, it was not an issue to know whether something was generated by a human or because there was hardly any AI-generated content out there. But now, in order for us to know what's true and what's not, what is original and genuine content made by a human and which one's not, it's not an easy topic. And with ZK, you could actually attach a validity proof or like a proof to it saying this content has been, like proving that this certain content has been generated by a human. Or, for example, even there are use cases where, for example, the cameras, it can be proven that the photo taken by a certain camera has been altered or not. And in that case, it's very interesting because nowadays it's super, like I feel when I'm online that I'm getting skeptical when I see different content. So I think that could be a very application of ZK as well. But also we could talk about ZK identity solutions. You could talk about, I don't know, proving your credit score to a bank without needing to reveal all your private data and financial data, etc., that is underlying there. With ZK, and particularly with applying the privacy aspect of ZK, you could also prove these things. So I do think that the technology and the real-world use of the technology will go far beyond just blockchain itself.
Yeah, I've heard that the technology itself was existent even before the invention of the blockchain itself.
Absolutely, actually,
so
that's
true. So I wonder what it was used for at that ancient time.
Yes, actually, I think for a very long time it was more on the academic realm, where it was researched and applied. And then with the emergence of blockchains, actually it's a very good fit to be applied in the blockchain space.
Yeah, that's totally true. But let's stick to the blockchain topic. And here in Gateway, we deploy dedicated blockchain rollups for our clients, for projects that would need a dedicated network. So when we are deploying ZK rollup, we need to generate this ZK proof. And for this particular purpose, we use very expensive powerful machines, computers, so one machine per one rollup. So can you provide any other better solution for this? Because I don't think it's pretty efficient to do this way.
Yes, absolutely. Actually, that's the issue or the situation we are looking to solve with Gevulot. So basically, as I mentioned in the short TLDR about Gevulot, we are building a network that is fast, cheap, and decentralized. And what it means is that one of the main goals to establish Gevulot was to drastically decrease the cost of proving. Because what we see is that the cost of proving is one of the main bottlenecks out there currently. And as soon as we are able to bring down these costs significantly, we also expect a whole lot of new use cases to become economically viable because cost will not be a bottleneck or like a showstopper anymore. And it seems based on, we've been working on this for several months and it seems to be absolutely possible. Proving is going to get cheap. And the other key element that we've been focusing on is that we wanted to avoid a situation similar to Web 2, where compute power or compute resources became extremely centralized with Amazon or Google Cloud, etc. And since proof generation is a compute-heavy task, it is very susceptible to centralization as well. So we thought it's important to create a viable alternative, a decentralized alternative to these other centralized solutions, because even though it's super convenient for any team, and many of the teams do that to spin up a machine on AWS, proving is never going to get cheap if we stick to that practice, basically. And also, if you run your own server, for example, you rent a server to generate the proofs for your rollup or for your clients, In that case, whenever there is no need for proofs, you are actually still paying for your server, or you may still be paying for your server, which means that there is a lot of idle time and like wasted cost for idle compute time.
Yeah, and, actually the cost aspect is one of the biggest skeptical.
Exactly.
What makes people skeptical about this ZK rollups? Many will go for optimistic stack because it's cheaper. But you know, with this optimistic stack, you always have the 7 days you have to wait before you can withdraw your asset.
I'm absolutely with you, yes.
So we need to get this technology cheaper to use in order to get mass adoption.
So basically, I think in a nutshell, if I may go a little deeper, the way we approach building our platform is that we are building a universal proving layer. And it's universal because we support any proof system out there. It means we support the entire set of ZK-EVMs, but also general purpose ZK-VMs out there. But not only can you generate proofs on Gevulot for pre-deployed programs or pre-deployed provers that our team have integrated with, but you can also kind of bring your own prover binary, deploy it easily on Gevulot, and then start generating proofs for your own custom circuits, or let's say there is an existing ZK-EVM on top of which you'd like to do additional optimizations and use that for yourself. You can deploy that easily also on Gevulot, and like with the same properties as the pre-deployed prover programs, you can have proofs generated for your own program as well. So in terms of integration with Gevulot or using Gevulot, it's super flexible actually. On the other hand, it serves the purpose of being able to aggregate workloads all across the industry, because aggregating workloads helps us to decrease and drive down the cost of proving also, because we are able to reach a higher network utilization or a higher hardware utilization for our prover nodes as well. On the other hand, we have this universal proving layer, but then we have an orchestration layer which makes sure that we can efficiently produce those proofs. So we can efficiently orchestrate basically within nodes to parallel process proofs, but also apply multiple nodes if the proving window makes it necessary, or the prover program is designed such that it needs multiple machines to be run and to parallel proof certain parts of the workload. And all this orchestration layer is basically managed by a very lightweight blockchain. It's a Cosmos-based chain that we have built, and it basically only serves the purpose of distributing workloads and distributing rewards, or managing the economics in the network.
Yeah, coming back to stack, differences in stack,
Yep.
like technologies. You mentioned that you support different kind of ZK-EVM networks.
Yes.
Do they need the same type of ZK proofs?
That's a very good question. Yes, we support the Polygon ZK-EVM and any chain built on top of the Polygon CDK stack based on the ZK-EVM. We also support the Scroll SDK, just finalizing the integration now. So any chain building on that stack can also be proven through Gevulot, and we are looking to integrate with Linea as well. And these different provers, these different ZK-EVMs have different hardware requirements, because as of now, the Polygon ZK-EVM, for example, does not by default utilize GPUs. So for that, you need a very powerful CPU machine with at least something like 90 to 100 cores and like 800 gigs of RAM to be able to run that efficiently. On the other hand, for example, the Scroll SDK and Scroll's ZK-EVM support GPU acceleration. And at Gevulot, we can manage both types of proving. So we have CPU nodes, CPU prover nodes in the network, but we also have very powerful GPU nodes And depending on the requirements of the different provers, you can actually utilize both of them so that we can process both types of proofs efficiently.
Do I get it right that you are like handling differently, separately, requests for proofs coming from Polygon and requests for proofs coming, for example, from Linear?
Absolutely.
And they are handled on separate machines. Like you have not one decentralized network of provers, but several, according to each protocol, because each protocol needs, has its own requirements for the provers.
Actually, we don't need multiple networks because our machines are general and powerful enough to be able to handle any of these proofs. But the hardware resources allocated to a Polygon ZK-EVM request or for a linear request would be different. And the way it works is, yes, if we are talking about it from a practical perspective, then it means a sequencer on a Polygon ZK-EVM based chain would bundle up the transactions, build the block, and would send the inputs, would send a request to Gevulot to prove that block. And what they would do is actually they reference the hash ID of the Polygon ZK-EVM prover, so we know this request has to be executed on that prover program. Then they send the inputs, they send a URL where the inputs are available, and they can also tell us the amount of compute resources they want to be allocated to this particular request, and also the time, how long we should be running basically that program with the inputs and with the allocated hardware resources. And then we basically execute the job, we generate the proof, and we make it available for the requester or the sequencer of that rollup. However, in order to ease their life as well, since, for example, proving a Polygon ZK-EVM based chain would have very similar types of requests, but maybe different sized inputs. Maybe one block would have more transactions while the other has less. Basically, not necessarily would the sequencer at all times need to define those hardware requirements, because we can set up a predefined amount of hardware to be allocated for the program, and whatever request comes in, it can be run with the default hardware and then generated efficiently. In case of a larger input, larger number of transactions in a block, for example, it would probably take a bit longer. In case of a smaller number of transactions, it would take shorter. I'm just talking at very high level now. But if needed, users can customize basically the allocated hardware according to their preferences or according to their priorities and the available proof time window or proving time window.
And in terms of efficiency and cost efficiency, which protocol, which network has the best requirements for provers?
Actually, to be honest, we are pretty agnostic in that sense, because basically a GPU node on Gevulot has 64 cores, almost 400 gigs of RAM, and two 4090s, two GPUs, each a 4090. And basically, the entire capacity of this node for 1 hour costs something like 80 cents or something like that. And in case, for example, and this is standard across the board, whatever prover and whatever proof request comes in need of a GPU node, the compute cost is by default the same. However, we apply a pay-as-you-go model. So the requester will only pay for the amount of hardware resources allocated and for the time they use it. So in case they tell us, we only need half of your GPU node and only use it for 10 minutes, then that's what they pay, proportionally from the 80-cent hourly cost and the entire capacity.
So that makes sense, yeah. But if I decide on which technology, what protocol to use, and my only factor to decide is the cost of ZK provers, so which protocol would you recommend me? The most efficient in terms of costs?
Well, it's a hard question. I do have some numbers for some of the stacks. For example, how much it would cost to prove the scroll SDK, a scroll SDK based chain, for example. But I don't have by heart the numbers for the Polygon ZK-EVM. Overall, I think just for the audience, 80 cents an hour for a dual GPU node with 64 cores and 400 gigs of RAM, it translates to like $600 a month approximately, which is very cheap. So it's about 90% cheaper than when you go to, let's say, AWS, and you would want to rent a similar performance, a similar machine with identical performance capabilities.
Seems like if we are utilizing your technology in our rollups, that means like less costly service for the end user, for a project to less costly to maintain his dedicated network.
Absolutely. So it is realistic that we can drive down the costs by about 90% compared to traditional cloud compute providers. And that would mean that what you referred to initially when you mentioned optimistic rollups, and it's much cheaper to run an optimistic rollup than a validity rollup or a ZK rollup. It's indeed true, but the gap is closing up, and we are bringing in very cheap and very efficient proving. And also, I think it's worth touching a little bit upon decentralization, because centralization in itself is not necessarily an issue, but in a centralized setup, it is very easy to censor transactions or censor blocks and say, I'm not proving this because it includes certain transactions that I don't want to prove. Or a centralized entity can very easily basically dominate and influence the cost of proving. And also there may be liveness risks as well. But overall, what you get with a decentralized network is that you have much better execution guarantees, liveness guarantees, much higher censorship resistance, and it all boils down to a much more performant proving service for our users.
And what infrastructure have you used to build your own blockchain for these purposes of decentralization? Was it L2 or L1 solution? Was it private blockchain or public blockchain?
We used the Cosmos SDK to build our own public L1. It was important for us to have this because this way we can have full flexibility to design economics. In other words, if we build on an L2 or if we build on another L1, then we inherit the economics, the fee structure of the underlying blockchain. And in order for us to be able to drive down the costs drastically, we basically had to have our own blockchain, but it's a very minimal chain, very minimal operations. We don't host smart contract state. So basically it's there to manage workload distribution and to handle the economics within our chain.
How did you come up with the decision to use Cosmos, and what factors do you take into account when making such decisions?
Mm-hmm. We've been considering some other stacks as well, but overall, and also specifically considering that we are looking to have a sub-second block time in order to minimize the added latency for any proof request. We finally decided to go with the Cosmos stack. All the others would have required much more, or would have added a lot more complexity to us going to the market and like building our own chain. So Cosmos was a very good fit for us, but probably our CTO could dive deeper into those decisions behind this. But yes, in a nutshell, that was basically a key factor, so that we can we have a very battle-tested stack with which we can safely reach sub-second block time, with the networking overhead still being manageable.
Okay, I see. So that's a thoughtful decision.
Yes.
And tell me, please, like since you are working in this ZK area, how do you think, what are the main challenges of ZK-EVM stack? What are the main challenges of ZK area as a whole?
I think I'm a little bit biased, I think, because I tend to think from the perspective of proving infrastructure. And I think the infrastructure is quite fragmented. The space is quite fragmented in that sense. So what I mean is that any team looking to outsource their proving has a quite complex landscape to look at, and it's not an easy task to figure out what is, like, which team or which proof provider provides the optimal solution for them. And exactly for that reason are we building a universal proving layer, so that we can support basically any of the provers and any stack out there. On the other hand, we also launched an initiative a couple of months ago called ZK Boost, and we have formed a consortium, a ZK Boost consortium. Basically, we managed to onboard about 40 industry teams, very well-known names in the industry for this. And what ZK Boost is doing, it's a piece of software that stands between any proving service and anyone who needs ZK proofs. And we want to make it very easy with a standardized API. We want to make it very easy to outsource proving. So the way to imagine it is that, for example, a rollup or a ZK application in need of proofs could send their request to this API, which on the other side provides them all the different proving options, and it's super easy to find the optimal one. Basically, it abstracts away the complexity of finding the right proving solution for them. And I think it's very important because fragmentation is not good. Like, it creates a very bad user experience. It makes it very hard to outsource proving. But also, I think it's a very, so ZK Boost as a concept and the software that all these 40 teams are building together is going to help a lot for teams to outsource proving, and will make it very easy to work within the proof supply chain.
Yeah, a lot of work is being done right now to enhance this ZK technology and about better collaboration between industry players to achieve more like adoption rate among companies of this ZK rollups and ZK technology as a whole. So yeah, I believe we should do more work together, more collaboration to achieve less fragmented industry and give the technology a way to reach the customer.
Absolutely. And our goal is to support any of the stacks out there. So we've talked about the Polygon ZK-EVM and the Polygon CDK stack, also the Scroll SDK. Linea is in the pipeline to support any chain building on Linea as well. I think you mentioned earlier Linea.
Yeah, we are working with Linea and Scroll and Polygon CDK as well.
And basically, we are launching our production-ready scalable network now, which is the end-to-end implementation of ZK Cloud. By the way, it's funny, we've been talking for, I don't know, several minutes, but basically the word ZK Cloud hasn't been mentioned. That's the name of our permissionless decentralized chain that we are building, the universal proving layer. It's called ZK Cloud. And the network we are launching now is called Firestarter. It's the end-to-end implementation of ZK Cloud with one difference. We run the validator set in the chain ourselves, but proving is already decentralized. And as a next step, we are going to test decentralizing the validator set as well, and then launch the final ZK cloud, which is going to be entirely permissionless and decentralized, both on the validator node and on the prover node side.
So you are running two different networks?
Actually, there is one network, but two network actors, basically. Our blockchain needs to have its own set of validators to manage building the blocks, to form consensus, etc. On the other hand, we have another network actor, which is separate from the validators, but it doesn't need a separate chain, absolutely. Prover nodes, and the prover nodes are directly communicating with the chain, picking up jobs and making proofs available for our users. So it's one chain, but two network actors, kind of like a dual node architecture, if I want to be like very specific.
Yeah, that sounds great. So thank you very much for this discussion. Thank you for coming to our podcast, and I'm looking forward to having you again in our studio.
Thank you very much for having me, and thank you very much for the talk.
Thanks.